Hello, everyone. Today we are going to take a look at Chapter 7.2 in our textbook, and the topic is what affects the margin of error. And our objectives for today are going to be to interpret a confidence level in context, and also to determine how the confidence level and sample size can affect your margin of error. So, to begin, if I would have had you in class today, we would have tried this activity out, but what I'm going to do is summarize this for you and hopefully answer the question of what exactly do we mean when we say we're 95% confident. So let me take you guys over to this applet here, and I will post a link for you to try this out on your own. So this is called the confidence interval applet, and what you're going to notice down here is a confidence level meter that we can adjust from 80% all the way to 99.5, but we're going to start off at 95% confidence. A sample size button that goes anywhere from 5 to 250. So I'm going to go ahead and leave that at 20, which is where it was initially starting at. Alright, so I'm going to hit this sample button, and what's going to happen here is we're going to try to capture this unknown parameter mu. We don't know what it is, but we're going to construct this interval to try to capture this parameter. So first time I hit sample, we capture the parameter, and this is the size and the width of our interval. I'm going to hit sample a total of 10 times. And you're going to notice I've been 100% successful in capturing that parameter. Now, let me sample 25 at a time here. And when I do that, you'll notice now I'm finally missing the true parameter. There's 2 here that totally miss, but there's 33 that actually do capture the true parameter. Now let me just tap this a lot of times here. And the idea is that hopefully you'll see I've captured the true parameter 96% of the time. I've caught 780 out of 810. So it's not exactly 95, but it's very close. All right. So now let me reset that, and I'm going to change this to, let's say, 90% confidence. And I'm going to skip to sample 25. And you'll notice, after 25, I've only captured 80%. I've captured that true parameter 80% of the time. Let me hit this a few times. Let me go to about, let's go to about 1,000 here. And hopefully you'll notice as I repeat this process, our capturing of the parameter is 89%, which is very close to 90%. Okay, so that brings us back here to what we mean by the confidence level. So when we say we're 95% confident in something, this means if we take many samples of the same size from a population, about 95% of these samples will result in an interval that captures the actual parameter value. Okay, so I want you guys to go ahead and just pause the video and copy this interpretation down, because we are going to practice interpreting a confidence level today as opposed to the interval. So copy this down, and we will talk about how we're going to do this in just a moment. All right, so let me go ahead and read through this. So it says, to interpret a confidence level C, say, if we were to select many random samples from a population and construct a C% confidence interval using each sample, about C% of the intervals would capture the parameter in context. Okay, so a couple of notes down here. Make sure that you don't interpret the confidence interval when asked to interpret a confidence level, and vice versa. Our last lesson was focused on interpreting a confidence interval. Okay, you'll notice in the confidence level interpretation, there's no mention of the actual numbers used to construct the interval. Another important note is confidence levels describe the process used to make an interval, not the actual interval itself. Okay, so that's a major difference that you'll notice from what we talked about last week. All right, so I am going to skip through a couple of these slides here, and let's take a look at this. I apologize for that right there. Let me move that. All right, so in this example, it says that the Pew Internet and American Life Project asked a random sample of 2,253 U.S. adults, do you ever use Twitter or another service to share updates about yourself or to see updates about others? In the sample, 19% said yes. According to Pew, the resulting 95% confidence interval is 0.167 to 0.213. Now remember, when you're interpreting the confidence level, these two values of the interval itself, we are not going to mention at all. All right, so here's how you would interpret the confidence level. So what I did in blue here is I put some of the context in, and in red I have our confidence level. So if the Pew Project took many random samples of U.S. adults, this is our population, and constructed a 95% confidence interval using each sample, about 95% of these intervals, sorry about the typo, would capture the true proportion of all U.S. adults who use Twitter or another service to share updates about themselves or see updates about others. So here, remember to be careful when you're working with either a mean or a proportion. Here, this is a proportion. You've got your interval, if you go back and look, was in a proportion form. So make sure that this word is proportion when you're working with percentages or data that's categorical. Make sure it's mean when you have quantitative data. All right, so let's try this problem out here. So go ahead and pause the video if you need to. And I want you to interpret the confidence level for this particular question. All right, so hopefully you took a moment and tried this out on your own. We'll go through it, we'll read through the problem and try it together. So based on a random sample of 10 students, a counselor calculates that the 95% confidence interval for the population mean amount of sleep from the previous night for all students at her school is 5.39 to 7.81 hours. We're going to interpret the confidence level. All right, so in our solution here we have, if the counselor were to select many random samples of 10 students at this school and construct a 95% confidence interval using each sample, about 95% of the intervals would capture the true mean amount of sleep for the previous night for all students at the school. All right, so remember, this word will typically either be proportion or mean. All right, so in this case, the data was quantitative, so we are trying to capture the true mean amount of sleep, and that's our parameter in the context. All right, so moving on. Now, what affects the margin of error? All right, so in general, we do prefer an estimate with a smaller margin of error, and this is how you can get the margin of error smaller. All right, so for one, you can decrease the confidence level. So as you see here, you have two different intervals with the different confidence levels. So when you decrease confidence, you would get a more narrow interval, which results in a smaller margin of error. Now, the higher confidence level, the 95 compared to the 90, you'll notice a much wider interval, and as a result, more margin of error. All right, so one way to decrease it is to decrease the confidence level. All right, now a second way to decrease margin of error is to up your sample size. So you can, if you increase the sample size, you can get a lower margin of error. So let me summarize that with some diagrams here. So if you want to decrease margin of error, you can decrease your confidence level, your C level. All right, and there's a direct relationship between these two. So if, let's say, margin of error goes up, that could be because your C level went up. Okay, if your C level goes up, your margin of error goes up. If your margin of error goes down, your confidence level probably went down. So there's a direct relationship between those two. Now, on the other side, we can also decrease margin of error by increasing sample size. So, oops, pardon me. So we can increase n and we can decrease margin of error. All right, so this is more of an inverse relationship, so you can think of it this way too. If your n, or your sample size, is low, you're going to have a higher margin of error. All right, so those are two things that can definitely affect the margin of error. All right, I'm going to take you back to this cartoon about Garfield to illustrate one of those ideas there. So in this cartoon, the weatherman says the high temperature will be between 40 below and 200 above. And this weatherman is probably 100% confident in that. And, you know, he's got such a wide interval. Think of this as a number line here, with negative 40 at one endpoint and 200 at the other endpoint. And he's got such a wide interval, but as a result, he's got a high confidence level. So he's got a lot of margin of error in that calculation. The wide interval corresponds with a large margin of error, and that's partially due to his very, very high confidence in that. Now, he may say something like this instead. He can say, you know, I predict the weather will be between 70 and 80. But when he gets that very narrow interval from 70 to 80, he is now going to have to be much less confident. So he may say this at, well, you know what, I'm only 80% confident that the high temperature will be between 70 and 80. Because of the lower confidence, he's got less margin of error. It's a narrower confidence interval. Okay, so just use this cartoon to kind of keep that one in mind, because that does illustrate. And I do want to go back to the applet and show you that for a given, couple things here. So for a given confidence level here, 90%, look at the size of these intervals. You'll notice as I up the confidence level, they're slowly getting larger and larger. So a 99% confidence level, all things being the same, has a bigger margin of error. It's wider than the 95%. And as I decrease confidence level, you'll notice the interval getting smaller and smaller. You'll notice they're getting very, very small, and that's due to that fact. Okay, so we're running out of time here, so let's finish up with our last example. So here, as part of a project about response bias, Ellery surveyed a random sample of 25 students from her school. One of the questions in the survey required students to state their GPA aloud. Based on the responses, Ellery said she was 90% confident that the interval from 3.14 to 3.52 captures the mean GPA for all students at her school. Explain what would happen to the length of the interval if the confidence level were increased to 99%. And how would a 90% confidence interval, based on a sample size of 200, compare to the original 90% interval? So in part A, we're gonna look at what happens when we up our confidence level, and then we're going to look at what happens when we up our sample size. So for part A, the confidence interval will be wider because increasing the confidence level increases margin of error. All right, so when you increase C level, you get a wider interval and your margin of error goes up. Now for part B, when your sample size goes up, your value of n, sample size goes up, your margin of error decreases, which gives you a narrower interval. So remember, sample size is inversely related to that margin of error, whereas that confidence level is directly related to margin of error. All right, one last problem for you to try out. So we're running out of time here, so please pause the video and read through it, and then we're going to take a look at the solutions. All right, so number one, interpreting the confidence level, we talked about that, so look at that example on your own. And number two, to reduce margin of error, we can increase sample size and reduce confidence level. That's it for today. I'll see you guys tomorrow.